Hello humans, welcome to the video. Ryan Lemon here, back in the saddle. Come on, let's take a ride. Multiplying polynomials, just like multiplying numbers. You've got 5 times 6, right? 1, 2, 3, 4, 5. 1, 2, 3, 4. 5 by 6, 30. We know this. 5 by 6. Well, what's the difference if you have x by x by 1, 2, 3. 1, 1, 1. Okay. Well, let's see. You've got, well, let's go back up top. You got 5 times 6, and of course that's 30, right? Well, what if you've got x times 2x plus 3? Some of you know right away that it's 2x squared plus 3x, because it's double rainbow time. X times 2x, and then x times 3. You multiply the number with the number and the variable with the variable. In this case, the number part of the first term is 1. Multiplying 2x, 1 times 2 is this 2. And then x times x is this x squared. And then 1 times 3 is this 3. And then you still have the x. Now, that's as simple as you get. Multiplying these. Here's a visual representation. You've got x by x. That's x squared. Then x times, here's x times x. Here's x times this x is x squared. Here's x times 1 is x. Here's x times this one is x. And here's x times this one is x. So you can notice the 2x squareds. And you can notice the 3x's. However you want to think about it, it's okay with me. Here's some more polynomials being multiplied together. And notice you've got a monomial multiplying a polynomial. So a single term outside multiplying a crazy polynomial inside these parentheses. The same rules apply. We're taking this idea out in front and multiplying the first term in the parentheses, and we're going to take that idea out in front and multiply the second term. So really what you have is just a big long strand of multiplication when you write this all out. Keep the integrity of what sign is in between here. 2x to the third times 3x to the second. Again, plus. I'm writing plus because the integrity of the sign is located within the term that it defines. So we've got 2x to the third is the term on the outside, multiplying this negative 2x. And you have this still 2x to the third, multiplying this is a positive 5. So there we have it. Seeing what's going on here, we've got this number times this number. So it's 1 times 2 for 2, and then you have this number times this number, x times x, but it's to the third power. So x to the third times x to the third is x to the 6. Remember, when multiplying things that have a similar base, you must add the exponents. More clearly represented here, x to the 5th, because you're adding those exponents. Let's get rid of that, and we can continue down the line here. We've got 2x to the third multiplying 3x squared. Again, number with number for a 6, and variable with variable. X squared times x to the third is x to the 5th. Moving on. Careful here, number is positive 2, number is negative 2, so negative 4x to the 4th, because you have 3 with 1 is 4. And lastly, the number with the number is 10, and there's no variables besides the x to the third. Are there any like terms in this expression? Answer, no. So this is the expression that is the product of 2x to the third times the quantity of x to the third plus 3x to the second minus 2x plus 5. The product is right there in the box. Delicioso! Here's another example that's just worked out for you. You can pause the video if you need another look at a monomial times a polynomial. We're going to move on to a binomial times a binomial. What? Now, before we do this complicated multiplication problem, what I want to do is reintroduce you to the idea of 12 times 12, if you've forgotten, is 144. But we can manipulate 12 into 10 plus 2, and if you multiply 10 plus 2 times, how about even 16 minus 4, you will get the same result, because you have 12 multiplying 12. Let's see if this really works. 10 plus 2, if it's by 16 and a negative 4, what's the result? Well, you have 10 times 16 is 160, and you have 16 by 2 is 32. See how they match up in that square, or rectangle in this case? Negative 4 with 10 is negative 40, and negative 4 again with 2 matches in this box here for negative 8. Now this is a roundabout way, as you notice. Here's 160 and here's 32. That together is 192. How about the negative 40 and the negative 8? Negative 48. What's 192 minus 48? Well, guess what? It's 144. So no matter how you slice it, as long as you have the same idea in here, you're going to end up with the same result as 12 times 12. So with this idea, this is making it clear that you can multiply something that looks very similar to it in the same way. So that's how we're going to multiply this thing. Notice, again down here we took 16 and multiplied the 10, and then we took 16 and multiplied the 2. Or you can think about it the other way. We took 10 and multiplied the 16, and then we took 10 and multiplied the negative 4. Notice, took 10, multiplied the 16, and 10 multiplied the negative 4. So what we do is we're taking turns distributing the first term in this binomial to each of the terms in the second, and then we're taking the second turn is taking this second term in the first binomial and multiplying it by each of the terms in the second binomial. Interesting. Let's do it. Okie dokie. So we've got x and a negative 4 in the first binomial, and we're multiplying that by 3x and a positive 2 in the second binomial. Here we go. Again, we're basically taking this idea of x and distributing into the second binomial. So here's the x. Let's multiply 3x. How about 3x to the second? Here's the x. Let's multiply the 2. How about 2x? 2 multiplying x. And then we have the negative 4 part here. Negative 4, include the sign. Negative 4 multiplying this 3x, and then negative 4 multiplying the 2. Negative 4 with 3x is negative 12 for the number, and you still have the x. Negative 4 multiplying the 2 is negative 8. You still have to be conscious if there's any like terms, because what we have right now, here's the first idea we came up with, the second, then we have this negative 12x, then we have this negative 8. But you noticed like terms here. So the result, when combining like terms, is this here. So the product of the two binomials at the top is simply this. Fun stuff. Let's try another one. Here's another product. We've got 4n minus 1, that binomial, multiplying n plus 5. So if you fancied the box method, we can do that again. You have 4n in the first binomial and negative 1. And that's going to be multiplying n and 5. You can split this up into the product of all of these separate ideas. First taking 4n from the first one, and you're going to give that out to the second one. 4n multiplying n is 4n squared. 4n multiplying 5 is, careful, 20n. Alright, let's take the idea of negative 1. What's happening with negative 1? You're multiplying the n, and then you're multiplying the 5. Negative 1 multiplying the n, negative n, and negative 1 multiplying the 5. Match up in this box here for negative 5. Be careful that you've represented each and every term, and be careful that you've combined any like terms that happen to go together. And notice the like terms have, in both cases, been located in these boxes. Not necessarily the case, but it's cute, right? Okay, 19n for the combination of our like terms, and that's a positive 19n, and you still have that negative 5 at the end. It looks like the product of these two binomials is 4n squared plus 19n minus 5. Now, Mr. Lemon, do I have to do the box thing? No, but it's helpful. You will get to a point where you notice you've got 4n minus 1, and that's multiplying n plus 5. So you could take 4n and multiply n and put that result there. This is how I would write it initially. 4n multiplying a positive 5 and 4n multiplying a positive 5. And I would keep going horizontally, but I don't have enough space. So I'm going to say, now we take the negative 1 and multiply the n, negative 1 multiplying n. And then we have negative 1 again, be careful, multiplying the 5. What do we have in total? Here's 4n squared from this product. Here's another product for 20 n's. Here's another product for negative n. Here's another product for negative 5. Notice we have the same exact terms right there. So when we simplify, we should get what's right there. Whew, this is fun. This is exciting because we're about to talk about quadratics, and quadratics are amazing. That's all I want to say about that. Let's keep going. Mr. Lemon, what happens when we have a binomial multiplying a trinomial? What changes? Answer, nothing. Watch. You have 3b and a negative 4 by, you can make a little rectangle. In the second polynomial, which happens to be a trinomial, you have b squared. You list the terms. You have a positive 6b and you have a negative 7. So yes, we could actually split this up like so. The first result, these two multiply for 3b to the third. Then you have 3b multiplying 6b. Again, notice, here's 3b. Let's multiply this, then let's multiply this, then let's multiply this. So we're taking 3b and we're multiplying 6b now for 18b squared. And then you're multiplying 3b times the negative 7 for negative 21b. The negative 4 will then multiply each of the terms in the trinomial for negative 4b squared. Negative 4 is multiplying 6b, negative 24b, and then negative 4 times negative 7 for 28. Any like terms is a question you should be asking. Found a couple. Actually, found a couple more. So be careful when you're adding these up at the end. You've got 3b to the third because it doesn't have any friends. And then you have negative, what is that, 14. It's a positive, positive 14b squared with these two. And then you have, what is this, negative, same sign sum, and is that 45b with 28. I think that's the resulting polynomial when multiplying this binomial by this trinomial. Pretty crazy stuff. I'll walk you through one more. Here's another product, seemingly intimidating, but let's see what's really going on. You can arrange these in either way because the commutative property tells us that a times b is the same as b times a. So whatever you feel most comfortable writing first, you can do that. Either way you slice it, you're going to end up taking this 2x squared and multiplying here, and then you take the 2x squared and multiply there. So really, you could actually say 2x squared is multiplying this whole idea. Just like you can say this next term, which is 5x's, is also multiplying that whole idea, and just like you can say this last term of negative 1 is multiplying that whole idea right there. Interesting. Now, you could say That was just a dramatic pause for no reason. Okay, let's keep going. You've got this multiplying here and then multiplying there. If you do that, you've got 2x squared. And now I'm being a little dramatic here, and I'm going to write every single term. Why, Mr. Lemon? Because I don't want to get it wrong. I'm going to show exactly what I'm doing and then do it. It just makes sense. Here's a 5x, and be careful, that's a -3 it's multiplying. And here's a -1 that's multiplying 4x's. And here's a -1, eek, that's multiplying -3. Okay, now, at the very beginning, number times number is 8. Variable times variable is x cubed. Whew. Okay, let's be careful not to make a silly mistake like that one. You notice I put a addition sign when really it should not be, and I can't erase it for some reason. So here's a negative, a beautiful one. -6x squared. Here's 20 x's that are squared. Here's, what is that? -15 with an x. And here's a -4 with an x. And a +3, because that's a -1 times a -3. All right, let's see in this beast of a problem if there are any like terms. I spy a couple, I spy a couple more. We've got this 8x to the third standing by himself plus 26x squared. Psych, not 26x squared. And again, I can't erase for some reason. This is a negative sign. Remember that beautiful negative that we put. This is a 14x squared, and it's positive. And you've got -19x's and 3. Whoa, that's pretty intense. This is again a positive 14x squared. That's pretty awesome. Let's do one more just to be sure. Okay, friends, here's another binomial times a trinomial. Again, you're just taking each part of the first and multiplying by every part of the second. The 2x needs to multiply every single one of those terms that are in the second. So let's set it up so that we can use the distributive property to give this 2 to every single one of those terms. And be careful, you also have the -4 that needs to be given to all of these terms in the second. Okay, now that we've got it set up, 2x's need to multiply 3x squared. And the same 2x's out in front need to multiply these 2x's. And lastly, the 2x's out in front need to multiply the -4. Sick! So let's consolidate this idea before we even go on to the second idea underlined in blue. Here's the first idea with 2 times 3 being 6x to the third, because x times x is x to the third. And then you have 4x squared from this result. And lastly, -8x's. When we distribute this -4, we can have -4 times 3x squared. -4 will then multiply 2x's, and then -4 will multiply this, -4. Cool beans. The first result is -12x squared. The second is -8x's, and the third is +16. Go ahead and search. See if you can find them. Here's a couple. There's a couple. And the result is this. Now you can pause the video if I've gone too fast. That's the awesome idea here with this technology. You can go back and look at it at your leisure. Now I think this is right. I'm not sure that it is. This is plus negative for the second term in this polynomial that results from multiplying the two original binomial and trinomial. All right, have fun, explore. The homework is on the next slide. Here's your homework, friends. Enjoy.